good afternoon. Today we're going to talk about graphing the tangent function, y equals tangent of x. All right. To do so, again, we're going to think back to our unit circle, and we're only going to focus on graphing the quadrantals of tangent. All right. Now, with the quadrantals, I've got 0, I've got pi over 2, I've got pi, I've got 3 pi over 2, I've got 2 pi. Okay. Now, on my graph, if I take those quadrantals and place them on an xy coordinate sidewise, or a normal xy plane, I would have x here, y here. I would have, again, pi over 2, pi, 3 pi over 2, and 2 pi. Okay. Now, to figure out tangent, as you recall, we used the ordered pairs on the quadrantals. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right? And we said that the first coordinate inside the ordered pair is a cosine of the angle, and the second coordinate is the sine of the angle. Then we went on to say that the tangent of an angle is equal to the sine of the angle over the cosine of the angle. Right? Okay, so then.
Hey, lady.
It's Mark and the Funky.
All right, so tangent, we said, is sine over cosine, right? So if I wanted to say find the tangent of 0 radians, right? Well, according to this, tangent of 0 radians would be sine would be 0 over cosine 1, 0, right? So I know that when x is 0 for tangent, y is 0, okay? So my first point on my tangent graph will be 0, 0. Now I'm going to go up to the second quadrantal angle, pi over 2. At pi over 2, if I plug a pi over 2 in, y equals tangent of pi over 2, well again, that would be the sine of pi over 2, which would be 1, over the cosine, which would be 0. Wait a minute, that's undefined. Well, don't forget that to represent an undefined amount on a graph, we use a vertical asymptote. So I'm going to come in and draw a vertical line there. At pi, the tangent of pi would be, well, sine is 0, cosine is 1, so 0. So when x is pi, y is 0 again. So I get another point. At 3 pi over 2, the tangent would be negative 1 over 0, so undefined again. So another vertical asymptote. All right. And then lastly at 2 pi, well, that's got to be the same thing as 0 since it's a coterminal angle. I would have another point. So the nice thing about tangent is as you can see, the graph of tangent, the main features are only points and asymptotes. And it alternates. It goes point, then asymptote, then point, then asymptote, then point, then asymptote. Okay? Now, the next thing, to actually draw the curve, let's think about the quadrants. Would you agree from 0 to pi over 2, isn't that the first quadrant? Well, and we know that in the first quadrant, isn't tangent positive? Right, since all the functions are positive? Well, that means that from the origin, if I was going to go towards this asymptote, should I go up or should I go down? Well, again, since tangent is positive, shouldn't I go up? So my only curve in the first quadrant starts at the origin and goes up. Now, in the second quadrant, what's the sign of tangent? And again, I'm using the all students take classes idea. In the second quadrant, from here to here, I know that tangent is negative. So if I was going to draw a curve from this point here backwards towards the asymptote, shouldn't I go down below the x-axis to show that it's negative? Similarly, in the third quadrant, according to my all students take classes, tangent is positive. So from this point moving forward towards the second asymptote, shouldn't it go up into the positive x-axis, or a positive region of the y-axis? And then lastly, in the fourth quadrant, tangent is negative again. So again, as I go from this point back towards my asymptote, it would go downwards. Okay? Now, I want to do one more thing. I know that right here, again, is the fourth quadrant, right? Well, let's go back to the origin. If I went backwards by a quadrantal, would you agree if I went backwards to the left, wouldn't this be negative pi over 2, right? And wouldn't this end up being the negative first quadrant right here? Well, again, the negative first quadrant is the same thing as the fourth quadrant, and since tangent is negative in the fourth quadrant, it'll be negative in the negative first quadrant. And so I know that this graph is going to come down. Again, because negative pi over 2 is the same thing as 3 pi over 2, there must be a vertical asymptote there. And what I see here is another graph to the left that goes down from that point. All right, now, what you see here is a really developed graph of tangent. In fact, if you take a look, from this asymptote here to this asymptote here, don't you get this curve that's developed? And then from this asymptote to the next asymptote here, don't you get the same picture? Or the same, what's the definition that I gave you in your notes? It's the same cycle, right? Okay, so what that means is from asymptote to asymptote, I complete my picture or my cycle. So this, from here to here, is one cycle, so this length must be one period. Well, how far is it from negative pi over 2 to positive pi over 2? Or from positive pi over 2 to 3 pi over 2? Isn't that just 1 pi? Oops. Isn't that just 1 pi? So something interesting about tangent is his period is not the same thing as sine and cosine. His period is just single pi. It's just pi, right? Secondly, see how this graph goes up forever and down forever? Well, that means that if he goes up and down forever, there must be no amplitude for tangent. Since amplitude, by definition, is a maximum distance from the center line, or the center, since this doesn't have a maximum, since it goes up forever and down forever, I know that no matter what number I ever see in front of tangent, there must be no amplitude. So I always will write for amplitude for tangent, none, no matter what number you see there. Okay, it's kind of a trick question. All right? All right, you know what? I'm going to stop there for now, and we'll talk more about this in class tomorrow.